Hello everyone, I am Dr. Sirajul Akfaisi. I welcome you in my YouTube channel. Today in this video, I am going to talk on neutralization reactions and titrations. This is very important topic and we should clear our concept related to neutralization reactions and titrations. Neutralization reactions, a strong acid plus a strong base, it gives salt plus water. HCl plus sodium hydroxide gives sodium chloride and water. Neutral pH is equal to 7. Neutral solution results only if the acid and base are mixed in the mole ratios specified in the balanced equations. Now, titrations. A lab technique used to determine the unknown concentration of an acid or base using a neutralization reactions. Solutions of nitric acid and solution of sodium hydroxide. Sodium hydroxide dissociate and it gives sodium plus and OH minus. And nitric acid dissociated gives H plus and nitrate ion. Now, titration setup, you can see the burette, titrant and analyte. Titrant an acid base with a known concentration. Analyte a solution being analyzed. Burette glassware used to deliver the titrants. For example, if you had an acid of unknown concentration, you would add base with a known concentration to it until all the acid had been neutralized. At the very point that all the acid was gone, the amount of base you added would exactly equal the amount of acid you started with. Moles of acid is equal to moles of base. Now, the equation for titrations calculation is in neutralizations, moles of acid is equal to moles of base. So, Ma, Va, Mb, Vb. Ma acid molarity, Mb base molarity, Va acid volume, Vb base volume. So volume can be any units as long as they are the same on both sides. Now examples, titration volumes. If 5 ml of 1 molar sodium hydroxide was used to titrate 10 ml of nitric acid, what is the concentration of nitric acid? So Ma, Va is equal to MPVB. So Ma is equal to what? Va is equal to 10 ml, Mb is equal to 1 molar and Vb is equal to 5 ml. So Ma 10 ml is equal to 1 m into 5 ml. So Ma is equal to 1 into 5 divided by 10. So Ma is equal to 0.5 molar. Now, titration vocabulary. What is the meaning of equivalence point? The point in a titrations where the moles of acid is equal to moles of base. In point. Point at which the indicator changes color. The in point and the equivalence point are not always the same, but they should be. An indicator is used to determine when the acid has been neutralized in a titrations. Without an indicator, it would be impossible to know when the titration should stop unless you use the pH meter. So, titration of a strong acid with a strong base, such as sodium hydroxide and hydrochloric acid. Equivalence point occurs at pH 7. Should use as indicator that changes at a pH of 7, such as bromo, thymol, blue. So equivalent point here. So pH 7, volume of base. Now a strong acid, a strong base titration. You can calculate the volume of base needed to reach the equivalence point using the formula V dot in, V dot in. So there are three situations in which you determine pH. Initial strong concentration. This is simply the minus log H plus ion concentration, which is based on the acid. Equivalence point or end point when moles of OH minus is equal to moles of H plus. The pH is 7 due to autoionization of water. So before and after end point, calculates excess moles of H plus or OH minus, divide by the total volume and calculate the pH based on this value. You can see in this figure. Titration of a weak acid with a strong base, such as acetic acid and sodium hydroxide. Equivalence point occurs at a pH greater than 7. Should use an indicator that changes at a pH above 7, such as phenolphthalein. You know that the starting pH is higher and the equivalence point pH is higher. Friends, why is the equivalence point at pH greater than 7? The conjugate base of a weak acid is a strong base. You know, CH3COOH, acetic acid, weak acid, and acetate a strong base. Once all of the acid has been converted to acetate, it starts to take the H plus from H2O in solution and creating more OH minus ion, thus making the pH greater than 7. Now, weak acid and a strong base titration. You know, when a weak acid such as HC2H3O2 is neutralized by a strong base such as sodium hydroxide, the graph varies in two ways. First, the equivalence point is not at pH is equal to 7, and a buffer regions exist as you approach the end point. You can still calculate the volume of base needed to reach the equivalence point using the formula Vm and Pm. So, weak acid requires the same amount of base for neutralization as a strong acid because they dissociate as they are neutralized. Now, weak acid is strong base titrations. You can see the buffer regions halfway to equivalence point pH is equal to pKa. So end point or equivalence point, volume of base added in ml and pH is the y-axis. There are 5 situations in which you need to be able to calculate the pH. First, initial weak acid concentration. This is an ICE box calculation. The shortcut can be used here. Now, the second point, equivalence point, end point, is when all of the weak acid have been neutralized, they turn into the conjugate base. In this case, this is a hydrolysis problem. Calculate the C2H3O2 minus and then do an ICE box problem knowing that Kv. Calculate the OH minus and pOH and then the pH. Halfway to the equivalence points, you can calculate in this way. So my friends, before and after the halfway points, the pH can be calculated using the Henderson-Hasselbach equations or an ice box if you want. Use stoichiometry to determine the HA and A minus. You know the pH is equal to pKa plus log. So finally, after the equivalence point, the pH depends on the excess strong base that has been added. As in a strong acid-base titration, calculate excess moles of OH minus, divide by the total volume, and calculate the pH and then pH based on this value. The effect on the pH by A minus is negligible compared to the excess OH minus. So, weak acid, strong base titration. When a sample of weak acid base is titrated with a strong acid, the curve resembles an inverted weak acid, a strong base titration. You know, the pH at the equivalence point is less than 7. An indicator such as phenolphthalein that changes at pH of 9 would change when only 6 ml of acid had been added, even though the equivalence point is reacted at around 11 ml. So, acid base indicator must be chosen with a Ka near to the H plus of the equivalence point, and that is the pKa of indicator must match the pH of the equivalence point. So this is the color at low pH, methyl violet, malachite green, transitions pH, and color of high pH. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.